So we're going to do the late start, late finish pass. Now we've already determined how to do the early start and early finish. Well, now we're going to go and we're going to reverse our way back through this model to do a late start and late finish. So the latest that step F could start without delaying the project is going to be 13 weeks because that's the earliest start that H has. So that's going to be 13, and it's going to be 13 here. And this is an example of the entire path with the late start and late finish accomplished in it. So here we can see that F, the latest it can start without delaying the overall project, is 13 weeks. And that's different than the early finish and early start times. So if your late finish is 13 weeks, to determine your late start, you just subtract 3 weeks from 13 to get 10. And that's the latest you can start Project F without delaying the overall end date of this project. And so the quiz is going to ask about slack and where slack exists. And slack is when there's a difference between the early start and early finish time, because that means there's flexibility. If you have workers that can do either task F or task G, you can pull people off of F and have this one start a little bit later because it's not going to delay the overall end time of the project. You can use this with I'm using time, but you can use this for a number of different components of a project, budgetary concerns. But we're going to look at time to illustrate this. So activity F has slack, activity G has no slack. And to determine the critical path, it's going to be the path where there is no slack. Because again, any delay in the critical path will delay the overall project completion time. You can have delays here, you cannot have delays here. So let's route out the critical path. Well, it's going to go A, C, E, G, H. That is our critical path because there is no slack on there. If you can throw a bunch of money and crash one part of this project and have it take less time, then your critical path is going to change potentially. This might become your critical path as this becomes very efficient. So critical path, we did the trace. Great. Determining variance, there's a formula here where you're going to take the optimistic minus the pessimistic divided by 6, and you're going to get your standard deviation from that. Add up all your standard deviations, and you'll get a total amount. I'm not really concerned with you calculating this. I just want you to understand the principle. We get 1.76 weeks of standard deviation, and so when we're tasked with doing this in under 16 weeks, we expect to do it in 15 weeks. But there is variance, and there is a chance that we go over budget. And based on that standard deviation, there's a 71.6% chance that this project is completed in under 16 weeks. And I put this note here. Instead of using the formula provided, you could do a Monte Carlo analysis for each one of these steps and determine this as well. But we're not going to do that. I'm going to stop here, and then we'll finish up with regression and correlation.